As part of a research project, we did some training on the visual analysis of the sit-to-stand task, and this is from that project. So we can see here that the purpose of this project is to determine the accuracy of the observational assessments of the sit-to-stand for detecting the amount of leg force used by subjects post-hip fracture. And during this session, this study, we had started with the training of teaching therapists how to look at video recordings of people with hip fracture doing the sit-to-stand task. So this is meant to kind of introduce you somewhat to the way that we look at video and how you make judgments about left and right sided force. So recall that the sit-to-stand task is divided into 3 phases. The first phase is the preparation phase. It starts with the unweighting of the limb and then ends at the beginning of the rising phase when the seat comes off of the chair. That's the beginning of the rising phase then. And then the rising phase ends as the person reaches a fully erect position. And then the stabilization ends when their sway, the normal backward and forward sway of somebody during standing, returns to a normal amplitude. So this is a typical ground reaction force reading from the right and left leg of somebody doing a sit-to-stand task. So we can see the vertical forces are here on the y-axis, time is on the x-axis, and then the red is the left leg and the right is the blue leg. And we can see that the vertical forces between each leg, there's some amount of asymmetry, but for the most part, they're fairly consistent. So we're going to focus on for this talk is when we make observations and visually looking at a person rise, we're going to try to connect those visual cues to their symmetry of leg force and try to guess, is it the right or left leg that's pushing more? And we're going to use trunk movement, some cues about how the leg's transitioning, and then the kind of starting position of the subjects as they're rising. So we'll start with trunk movement at liftoff. So first, you want it to be smooth and controlled, and continuous forward motion. So a negative would be a non-continuous forward motion. Let's give an example. So this is a normal person rising. So let's see what you think. And if you watched, let's watch it again. Now focus on her trunk and foot positions. Do her knees stay abducted? Does her trunk sway back and forth forward, or is it just kind of a nice, consistent, fluid motion? Okay, so you can see that's a person without a hip fracture rising. And here's their ground reaction forces. We have the vertical here on the y-axis, time on the x. The red again is left and the blue is right, and we can see if we look at those that there's a small discrepancy, but for the most part the ground reaction forces are fairly symmetrical. And that's kind of what we expect when we have a person rising. So here's our first case, so see if you can pick up what kind of abnormality exists here. This is a patient with a hip fracture. We can see that she had to use her hand to get up, but I'll play it one more time, try to predict, because we're going to look at the ground reaction forces next, try to predict which side generates more ground reaction force to complete her rising. Okay, so here we go. So here we got, what's the blue again? Remember the blue, here's our vertical ground reaction force. We said the blue was the right, so if you said the right leg output more force, you'd be correct. Left leg was markedly less here as she goes to get up. And notice that she had to rock a couple times to get enough momentum to come up. So she obviously has some hip extensor and knee extensor weakness that's contributing to this motor control problem. But essentially here we have this loss of of just this large discrepancy between the left and the right vertical ground reaction force output. So now we'll switch to leg movements of unilateral versus bilateral. So hip adduction or internal rotation. So what's happening in terms of how the legs are positioned? Are the knees coming together or coming apart? That would be a combination if they're coming together of adduction, internal rotation. If they're coming apart or maintained apart, that's abduction and external rotation. And then are the feet moved? Do they slide backward or forward as part of the movement to stand up? So let's see what we see here. Okay, so did you notice what happened to her legs as she stood up? Watch again. See her knees come together right there? Okay, and now focus from there, now focus on the bigger picture so you know that she might have some hip abductor weakness, potentially, or just it may be more related to motor control than weakness. But let's see overall, which way does she shift her trunk? Okay, so based on what you saw, guess whether her right or left leg is contributing more to the push to get up. Then we'll switch to the next slide, which shows you. Okay, so here we saw for the lefts have it by not just a small amount, but a very large amount. So her left side's outputting 78% and her right foot only 22%. So 80% of the force that's required to get up comes from the left leg. And that happens to be her injured side as well. Okay, so let's look at another one. Okay, see if you can perform some of the same assessments. Watch your feet and knees.
Go. Perfect.
Okay, now what did she, like, look at and see what she did with her feet when she got up. Let's watch it again. And what does that mean about her leg strength and which one she's relying on?
Perfect. Okay.
Okay, so if you said right leg, you would be correct. So here we have our ground reaction force. We see the blue is much higher than the left. Okay, so she slid her leg back after she leaned forward a couple times, but was able to get then her trunk leaning over that right leg, and then primarily used her right leg, again 80% right leg, to lift up. And so it was that initial sliding back of the foot that allowed her to get her weight underneath her trunk, her foot underneath her trunk, so she could push up with that left leg, and she left her right foot forward. Okay, so now we're going to talk about trunk movement, and this time instead of forward-back trunk movement, it's like side-to-side trunk shifting that we're going to look at and what that tells us about the ground reaction force under each leg. So here again, let's see what you assess here. Okay, so try to see if you can tell which way she was leaning, to the right or left as she comes up. Okay, based on that, try to guess which way she was biased in terms of using either the right or the left limb to stand up. Okay, so if you said left leg, you'd be correct. The left leg output, again, is about 72% of the force, and the right leg only at 30%. So that lean, so that subtle lean toward our helper here, is what made her bias her weight bearing onto her left leg. So that relates to that lateral trunk movement that we're getting you to cue in on. And here's another one that's even more obvious.
Go.
Okay, and I don't think we need to play that a second time. So here we have the left leg, weight bearing quite a bit more, but in this case less than the others. It's a 62% bias toward the left leg and 38% toward the right leg. So the trunk movement there clearly gave you a visual cue over which side was preferred. So the bottom line, can you determine symmetrical lower extremity force with visual cues? And can you estimate what percentage of weight bearing each leg is contributing to? And that was the question we asked in the study. So, and then the bottom line for the results we'll present in class. Thank you very much. I hope you enjoyed the videos.